Well, welcome. What do you think of my new background? Well, actually, it's not really new in the room that I make my videos, but I decided you guys could use a change. Instead of looking at a glass wall behind me, how about looking at a blue brick wall? See how you like it. Anyhow, in this video, I'm going to be breaking up this lesson into two parts. I'll do this on occasion. One of the reasons why I do this is sometimes you might want to go back and watch just one concept, and maybe the concept that you want to watch would have been in the middle of the video. Or this way, instead of having to find it by clicking and fast forwarding, you can just get to it a lot faster. So specifically in this video, we are going to be looking at how to find the slope of a line. The ultimate goal, though, for lesson 7 is this idea of the slope-intercept formula. But first, we need to understand what is slope. Great question. What is slope? Slope does a couple of things. Slope tells us how steep a line is. Now, the larger the number, the steeper the line. Now, you could have a positive slope or you could have a negative slope. A positive slope means that it's going to increase from left to right. However, a negative slope means it's going to be decreasing from left to right. We read a graph just like we would a book, from left to right. So from left to right, if it's increasing, if it's going up, we say it has a positive slope. If it's going down from left to right, we say it has a negative slope. Now we have a symbol that we use for slope, and that symbol is the letter M. Why do we use the letter M for slope? I don't know. Great question. I'm sure it'd be something that you could probably Google and find out. I'm sure it has something to do with the Latin phrase, what slope is. But you know what? Right now, we're just going to stick with the fact that it's just M. So anyhow, the slope of a line, we're going to use M to represent the slope. Now, how do we find the slope? Now, the way that we find a slope is it's what we call the vertical distance over the horizontal distance. Now, if you think about what we've been doing with graphing, the y-axis goes up and down, the x-axis goes horizontally. So the way that we're going to do this is we're going to say that it's the rise over the run, meaning how far from one coordinate to the next, how far up, and then how far over you need to go. A great way I like to explain it is, let's say you're sitting down right now in your chair, watching this video in the comfort of your room, and all of a sudden your mom yells, "Hey, I got a pizza ready for you," or "Hey, it's snack time," or "Hey, you could stop watching your math video," and you're super excited. You want to leave the room. What are you going to do first? You're going to get up out of the chair, and then you're going to run out of the room. Okay? So you have to rise first, and then run. That's how we're going to set up our fraction for slope. It's going to be the rise over the run. What does that look like? Well, let's look at this story problem. It says a girl making cards can make 2 cards in 1 hour. So let's say, if you look at the graph, let's say the x-axis represents the number of hours she's working, and the y-axis represents the number of cards she's making. So if you think about that, if she makes 2 cards in 1 hour, let's see what happened on the graph. We would have a point now that after 1 hour she'd have 2 cards done. Now she can continue working. It doesn't say that she has to stop after 1 hour. She could work another hour, and now she'd have 4 cards done in 2 hours. And she could even work even longer and get maybe as many as 6 cards done in 3 hours. So we could represent those points with a line. And that line has a slope. So the slope would be the rise over the run. And so in this situation, we're rising up 2 units and going over 1 unit, because she's making 2 cards every 1 hour. Now 2 over 1, really, that's not a great way to leave our fraction. Anytime we have a 1 in the denominator, we're just going to write our answer as the numerator. So 2 over 1 would just be 2. So the slope of that line would be 2. Let's look at another example. Now the girl is making cards, can make 5 cards in 1 hour. Show off. Okay, so she's making 5 cards in 1 hour. So again, we're going to use the x-axis as your hours. The y-axis is the number of cards. And so if we set this one up, she makes 5 cards in 1 hour, well, we can only fit 1 point on the graph, and so that would be our graph. So if we want to find the slope, again, she's making 5 cards in 1 hour. So the rise would be 5, and the run would be 1. So we just have 5 over 1, which we just said we'd simplify to be just 5. So the slope of that line would be 5. Why don't you go ahead and try this one on your own? So this one's slightly different. So again, on your notes, hopefully you're using lined paper or graph paper by now for these few lessons. But I want you to go ahead and make the grids. where the x-axis is going to be the hours, the y-axis will be the number of cards. And I want you to start at 0, 0, because again, if you think about it at the origin, 0, 0, she would make 0 cards in 0 hours. So that's kind of her starting point. So I want you to think about where it would be at if it was 1 card in 3 hours. Plot that point and figure out the slope. So pause the video if you haven't figured that out already. Pause the video and hit play when you're ready to check to see if you have it correct. All right, how'd you do? Well, should have gotten that again, that we would have at or in 3 hours she'd make that 1 card. You'd come up with a couple of points if you did that, and you have your line. So your slope in this case would be, again, rise over run. We would go up 1 over 3. So if you had 3 over 1, what you were saying is you were saying that she would make 3 cards in 1 hour. She's taking her time. She's making 1 card in 3 hours. And so your slope would be 1 over 3. And that can't be reduced. So that would be your answer. Why don't you try this one now? So a girl making cards can make 3 cards in 5 hours. So again, go ahead and make your XY axis, where X is still your hours, Y is still the number of cards. Find that slope. How did you do? Let's check. So you should have had that coordinate. It could only fit if you did your grid this big. And again, if you're wondering how big you need to make your grids on your graph paper, as long as you can fit 1 or 2 points, remember you only need 2 points to make a straight line. So as long as you have enough for that, you're good. All right, so this one, again, we could connect it with a line, but this time it was 3 cards in 5 hours. So your rise over run would be 3/5, and 3/5 can't be reduced, and so that would be your answer. So all of these examples so far have increased from left to right. What about this example? A girl loses $2 every day spending money on materials. So here she's maybe, for this card making business, she's losing $2 every day spending money on materials. So that means if 0 days have gone by and she's not spending any dollars, so she would be at 0, 0. So that's still our starting point. But now she's losing $2. So she's going down to over 1. So for every day she's losing $2. So after 2 days she would have lost $4. After 3 days she'd lost $6, and so on. So this also we could represent with a line. Now, anytime for your rise, instead of rising up, if you're having to rise down, which I know sounds like an oxymoron, but if you're doing the opposite, if you're rising down, it's going to be a negative slope. So our negative, in this case, would be a -2, so we're going down 2. We're still going to the right 1, so it would be -2 over 1. So our slope would be -2. Let's look at another example. This time a girl loses $3 every 2 days spending money on materials. Okay, so she's losing $3 this time every 2 days. So that means, again, we start at 0, 0. She's going to go down 3 because she's losing $3, but then she's going over 2 because she's losing $3 every 2 days. We can come up with another point if you wanted to and draw your line. So your slope for this would be -3 over 2 because she's losing $3 for every 2 days. But what if we have just a graph? What if we didn't have a story problem? What if we had a line like this? The first thing I want you to do is I want you to identify some points on that line. Meaning I want you to look at the grid and where that line intersects the grid. So now there's a lot of different points that happen here. And the reason why we want to pick these points is because it makes it easy for us to find the slope. Remember, the slope is the rise over the run. So for this graph, we're rising up 3 points. No matter which point we start at, we're always going to go rise up 3 units. And then from that, we're going to go to the left, or to the right 1 unit. So we're rising up 3 over 1. So the slope for this would be 3 over 1, which we can simplify to just be 3. Let's look at another one. Let's look at this one. So this one, as we look at it from left to right, we see it's decreasing. So this one should be a negative slope. Again, we want to come up with some points, though, where that line intersects the grid so we can easily pick one point to go to the next. So we're always going to go from the right to the left. Pick any of those points and figure out how do I get from that point to the next one. So for all of these, we would go down 1 unit, and then we'd go to the right 2 units. So for this one, the slope would be -1/2. Did you catch all that? That is the end of this video. So hopefully you have a better understanding of how to find slope, both from a story problem and from just by looking at a graph. If any of that was confusing to you, I encourage you to go back, make sure you're taking good notes, and rewatch parts of those videos. Whichever part of the video you didn't quite understand, make sure you watch it again, and maybe seeing it a second time around will help it click for you. But otherwise, now I want you to go on to the next video. Good luck.